and get our slides going. All right. Welcome, everyone. Thank you for joining us for session 11 of Cloud Native Beers with Engineers. I am one of your hosts, Will Hallam. And with me, as always, is Mike Gallagher. Just a quick rundown of our very informal agenda. We'll just cover why we're here, what the idea is behind this webinar series, do some brief intros. Then we'll go into a tech deep dive talking about health log analytics and Cribl Stream, followed by some live demonstrations. And then we'll wrap up with open Q&A. Why are we here? This somewhat existential question. The answer is the idea is to start to form a community of ServiceNow customers who are at a similar place in their journey to cloud native, and to share experiences and solutions that we found leveraging the ServiceNow platform to facilitate that journey and to make managing your cloud native estate easier. So now some host introductions. Mike?
So Mike Gallagher, been around the technology world for a long time. Lately, right, I've been focused heavily on this intersection of ServiceNow and cloud native capabilities. Super excited about what we're doing these days. And today I am going to be drinking a pumpkin spice latte, right? From Spice Trade Brewing, because you know 'tis the season for everything pumpkin, but it's a pumpkin spice latte beer, 6.7%, not too shabby. Will?
Nice. Thank you, sir. Will Hallam. I'm an ITOM architect over here at ServiceNow. Been in technology for a pretty decent amount of time. Focusing these days on IT operations management, automation, all the different cloud native and cloud provider related things. I really enjoy automating repetitive tasks. If I have to do something more than 5 times or so, I'm generally trying to find a way to automate it. And in my spare time, I enjoy hanging out with my family, playing some pickup hockey and video games. Oh, and I am going to be drinking a juicy ale from Saranac. It's 4.8%, which makes them fairly crushable for one of my favorite weekend beers. And yeah, so cheers. So with us today, we have a couple special guests from a company called Cribl. So Cam, Alex, if you want to just kind of give a little brief intro for your own selves before we get started with the main program.
Sure. Cam, I'm here. I work for Cribl. I'm the Director of Technical Alliances, and here to kind of spread the goodness of what Cribl can do to help out ServiceNow customers that are trying to get data into HLA. And I've been with Cribl now for 2 years, and I'm currently sitting, freezing my butt off apparently, in a wind tunnel here at Star Hill Brewery in McLean, Virginia, drinking their Little Red Rooster coffee cream stout.
Nice.
Nice.
Hey folks, I'm Alex Kane. I'm an Alliances engineer under Cam. I do technical integrations and kind of just live in code. I came from a background of operations work and development work. Spent several years at Splunk and Workday. Now just a little bit over a year now at Cribl. And I am sitting in my house in Raleigh drinking a 1985 juicy IPA.
Awesome. Love IPAs. Okay, without further ado, what we're going to start with is just a little bit of setting a baseline for the two components that are the focus of our session. Mike's going to start by covering some of the basics of health log analytics.
Yep. And and before I dive into this too deeply, just really quickly, I made it so that you guys can come off mute and ask questions if you'd like. Feel free to do that. As you guys know, we always like this when this is an interactive session, so don't hesitate to jump in if you have thoughts. So health log analytics and the shift in predictive AI ops, right? Really, on the left hand side is kind of the older model where we've build out these metrics and then we figure out here's what the threshold is, and then when that crosses and something breaks, we spend a bunch of time troubleshooting the logs, and then we go back into the cycle of, okay, we're going to build a new threshold in order to track this problem, only that problem probably never happens again, right? One of the things that we talk about is, as you know, services are getting more complex, that every event is a black swan event. Every event is a 1 in a million. And how could that have possibly happened? And yet, you know, we have black swan events happening almost every day. So you can't stay out in front of it in the traditional monitoring workflow, which is really where the predictive AI ops with AI and ML comes into play, right? On the right-hand side now, what we're doing is, as we're ingesting these logs, we're understanding what's normal, what's appropriate very, very quickly. We then can predict issues from those logs based on patterns, and the whole goal, right, ultimately is to really have a reduced mean time to repair, but also to have a lot less toil around, like, how do we actually solve the problem and manage a bunch of stuff that isn't really necessary or providing value to fixing things. So we move on to the next slide here. We'll kind of walk through a little bit more about the capabilities itself, right? So as we start to look at this, right, we're ingesting all of these events and all of this data set from all across all of these various different sources, right? And so health log analytics is just one component of the predictive AI ops platform, right? So it's another data source that we can use in order to correlate these things together. And ultimately, the goal is to then, once we have found, hey, we have an issue, something has arisen, now we can actually implement automated remediation against that incident, and be able to solve the problem as quickly as possible, and while, you know, reducing human intervention and the swivel chair efforts, right? I always talk about the human correlation engine, right? The goal of this is to take the humans out of that correlation engine, do a lot of that automatically, and then be able to repair it as quickly as possible so we can eliminate outages, all these outcomes here on the right hand side, right? That's the whole goal. So when we go on to the next slide, we can dive in a little bit deeper. So how does the health log analytics portion of that functionality work, right? This is an example of us ingesting log data from a particular log source, right? So we're seeing, hey, this client has prematurely closed the connection, right? Those are normal patterns that are occurring on a regular basis. And then this error pattern is another pattern that we're finding to be a new thing. So if you click and finish building that out, Will, right? What it does is it understands the text in order to build out, hey, here's what's going on, here's what's normal, right? And then this spike in that particular log pattern there is, hey, this is an alert that has occurred because this is an anomalous pattern that's outside of what we expect it to be. And so therefore we can generally alert on that before a normal monitoring issue can catch it, right? So instead of constantly chasing after, hey, this thing happened last time, which caused a break, and now we need to build a rule in order to try and catch that break before it happens again, right? Now the machine is learning what's normal and identifying patterns that are occurring outside of normal and potentially creating incidents around that. That way we can catch it as quickly as possible. So let's talk a little bit about how we get the data into the platform and what it looks like from an architecture perspective, right? So on the left-hand side here are the kind of the customer premise area, and the right-hand side is the ServiceNow data center instance capabilities, right? On the left-hand side, we have various different log shippers and various different log repositories that all need to feed the data into the mid servers in order to be able to get that data into the platform. And it's very similar to how we do with event management or other capabilities. Generally, we have a dedicated mid server that is ingesting that data, and that data comes in from a very specific stream, and we're looking for specific components or specific data. That then gets ingested into the load balancer that sits in front of the ServiceNow platform. And there's really the key thing to understand is that now glide component in the top left corner there of ServiceNow. That is your normal ServiceNow instance, right? And that handles all the UI and all the functionality for your normal ServiceNow work. The other three components, right, Occultus, Metric Base, and this DocStore DB, which is really Elasticsearch, those three are actually totally separate servers within the data center that are just sort of attached to the ServiceNow instance. And that is then the importance of that is that is actually splitting that off and then ingesting that data into those separate instances in order to prevent any impact to the primary ServiceNow platform, right? Because the AI engine and the time series data and that like longer term storage capability, hey, well, we're seeing that.
Yeah, my bad.
No worries. So all of that data is all ingested into those separate platforms, and it won't impact the actual usage of the main ServiceNow platform, which is a really important functionality because that's all fairly compute intensive use cases, right? So it's built and designed to scale separately and individually from the ServiceNow platform, and also cause as little impact as possible on the actual ServiceNow platform usage. Cool. So really, really high level overview. We're ingesting log data from the mid servers on the left from all the various sources and into the load balancer. And what's interesting about all those sources there is that all of those sources can be routed through Cribl, and use Cribl in order to do sort of that centralized aggregation and routing standpoint and we'll have them explain that since they'll do a much better job than I will. Any questions about HLA before we move on? Sorry, health log analytics. Okay. Over to the Cribl team then.
All right.
Awesome. Thank you, Mike. So go ahead and give you a quick technical overview. Rather than try to overdo this with slides. Go ahead and click on the next slide for me. This is literally what Cribl does. We collect data from any source and we route it. We can collect it, transform it, and also reduce it, or optimize, and then send it to any destination. In this case, we're talking about sending it into HLA or health log analytics. The benefit of having Cribl do all this work for you is that you have one place that you can manage the data collection of data, as well as route it to long-term storage. So the good news here is that you can take data, throw it into a data lake, whether that be an object store, S3, Snowflake, and later on down the road, if you need to replay it because you've run out of retention space on your login platform, you can do that using Cribl. So this is what our architecture looks like. I'll go ahead and click on the next slide. It goes a little deeper into kind of what we do. So we have a concept of leader node and worker nodes. Leader node is effectively where all the configuration changes happen, where people log in and make their changes. Those changes actually are stored in a Git repo, which are then pushed down to our worker. Our worker nodes can either be bare metal, they can be VMs, they can be containers. This whole thing can be containerized. And we can actually take this as a way to collect this data through the worker node, worker tier, and then ship it to whatever destinations we need to do. Let's see if there's a question. So, good question about the trade-offs. What we do is we are all about getting the events that really matter into the log analytics platform of choice. So there's a lot of times where there's like null values, there's data that is repetitive, there's unnecessary data that at the end of the day, if you send it into your logging platforms, it can potentially create additional load on your logging platform. So by eliminating that, you have faster search and full capabilities around. And the other piece of that is you can also route a full fidelity copy of all the events into an S3 bucket or object store that you can then later replay if you, for example, maybe took out a field that was really necessary for your analytics. So you can replay it back in and still have the full redundancy. So good question.
Yeah, I ran into that actually just as I was putting together this demo. I started out kind of drinking from the fire hose and just sending a lot of data in a lot of slightly different formats into HLA. And once something hits HLA, there's a little bit of adjustment generally that's required to kind of give HLA the right hints. So it's pulling out, you know, the correct timestamp, the correct severity, etc. And so it was very useful. And we'll get into that later when I kind of walk through the demo. It was very useful to be able to use Cribl as kind of that front end filter, so I could focus on all the logs from one of my microservices, for example, and then get that all nice and tight and working well. And then I could go back into Cribl and kind of add additional services in a very deliberate fashion, as opposed to having to kind of sort through it once it hits HLA, because that can get challenging. The AI does what the AI thinks it should do. And if you give it a lot of different formats of data all at the same time, it's, you know, sometimes it's a bit of work to kind of pluck the right pieces out to get, you know, that first microservice effectively monitored. So good, that's just a real life example of being able to kind of get that inspection on the front end before it hits HLA.
Yeah, one really quick thing, which I'm sure you'll cover there, is when you send the data in through Cribl, you actually see what the data is. So you can actually see a sample of the data as it's coming in. So you know what you're going to be taking out, what it looks like before and what it looks like after you actually process the data. So hopefully you can see it before you click go and you start sending data in about fields or variables. Good question. Yeah, so these are the common use cases that you can see with Cribl. Honestly, for people that are just getting data in, routing the data is probably one of the most like low-level, easy things to do with Cribl, but typically it's a very hard thing to do in real life. So timestamps, making sure that the events are properly formatted. Those are the kind of things that you'll start to see. We do a very good job of giving you that power. And ultimately, if you have data going into a system, you can optimize it so that you're dropping the fields that you don't need, formatting it in the proper formats that it needs to when it lands, routing it to multiple destinations. If you have a security team that needs it in SIM and you need the operations team needs it in HLA, you can route the same data to both destinations. So there's a lot of really cool, interesting things that we can do. Enriching data, adding asset information, adding GeoIP information, helping reduce the noise, get rid of things like personal identifiable information, PII, in logs, so you don't log that information in other systems. And then finally, again, being able to archive and replay data. All of this with one product that makes it very easy to kind of manage your data pipeline. Any questions on this side?
like we're good.
All right, next one. I think this is the last one. You can move that along. Hey, it's basically to help anybody that is doing POVs, targeting like sales engineers that, you know, one of their problems is getting data into their platform. We can obviously help with that and just make that whole process of showing the value of the actual like HLA faster than having to work about the plumbing of data into the system. And I never knew that this is actually an animation, so good to know.
Yeah, I realized it about 2 minutes ago.
So finally, there are 3 ways you can get Cribl. You can either use our Cribl Cloud, which is free. You can ingest 1 terabyte of data per day. It's available in US West and US East 1. It is free forever. Just log in and start sending data in. We have a downloadable product. You can download and run it locally. Again, a terabyte of data per day. And finally, we have this also available on Marketplace. So on AWS Marketplace, go download it, deploy it in your AWS account, and start playing with it. This is kind of just to show what we can do, what's exposed. We're taking in sources, we process the data through pipelines, and then based on certain filters, route the data to the appropriate destination through the appropriate pipeline. Any questions on this? And then finally, here is a leave behind. I would strongly encourage anyone that wants to play with Cribl to go to our sandbox. It's the full-blown version of our product, along with an explanation of how to use it. So you can actually go leverage the sandbox environment. Join our community. Feel free to talk to us via Slack. All of our training is free. It will always be free. So you can go get yourself certified in Cribl through our university. And you can also create content packs to help the community out. If there's a new data source that you want to develop, you can create the content pack for it in Cribl. And then finally, Curious is a great place to go see what other people are doing and answer questions or ask questions in a forum with like-minded individuals. All right, that's it for me.
All right. Thanks, Cam.
Oh.
All right. So now we'll go into the demonstration portion of the program. So what I'm going to cover is just a couple example scenarios where I found that Cribl plus HLA makes my life easier, can make our customers' life easier. So to do that, I'm going to introduce you to the basic elements that I put together for this little demo environment. And then once I kind of show you the pieces, I'll show you how they work together. And Cam, Alex, as I get into kind of the Cribl stuff, please don't be shy about augmenting what I've done with the actual kind of, you know, Cribl official best way to do things. Full disclosure, I'm kind of just I've just been figuring out Cribl by feel. It's been fairly easy. I found the documentation to be really helpful, and yeah, it's just made kind of plumbing these things together a lot easier than it would have been otherwise. So just running down the basic elements of my environment, since we're all about cloud native here at Cloud Native Beers with Engineers, I started with a Kubernetes cluster. So I've got this Kubernetes cluster here, which I then kind of threw a couple example workloads at. The most interesting one that's on here is based on the Google Boutique Git repo. And it's running a bunch of pods. which represent a bunch of microservices, which all function together to stand up a little demonstration boutique for ordering various bespoke objects. So this cluster is running in EKS in AWS. And because AWS kind of has their own idea about how to run a Kubernetes control plane, I couldn't just directly access the control plane logs using generic Kubernetes approaches. They kind of force you to go through CloudWatch to get your control plane log information. So in order to ingest logs from my control plane, I set up a Lambda function which would ingest those logs when they hit CloudWatch, and then just added a Lambda subscription to the corresponding CloudWatch log group for the cluster. And so this is just, well, highlighting's not going to work because that color is just terrible. So this is just a small Python script that I wrote, which essentially is taking CloudWatch logs, decoding them, decompressing them, and then forwarding them along to Cribl. And the Cribl destination is just populated via a URL on this particular line of code here. My plan is to put all the little code snippets and bits of collateral that went into this into a community article. So don't feel like you've got to like screenshot stuff or whatever. If you want this stuff to refer back to later, I'm going to put it all online, and we'll include the link to that when we send our traditional wrap up email for the session. So that takes care of my control plane logs. In order to send the logs from the individual microservice pods, I used a tool called FluentD. They are kind enough to provide several manifests which you can use. One of the great things about Cribl is that it speaks a lot of different languages, and one of the endpoints that Cribl automatically comes with when you use their free cloud cloud-based tenant is an Elasticsearch based endpoint, which will just sit there and listen for Elasticsearch connections. And as it happens, FluentD comes with a manifest which will deploy FluentD to your cluster with an Elasticsearch endpoint. And so all I did was I went into this manifest file, added my Cribl host as an Elasticsearch host, and added some authentication down a little lower, just so random people couldn't connect to my Cribl tenant and start sending logs into the Elastic endpoint, and fired this into my cluster. And so now I've got a FluentD pod running in each of my nodes, and it's just happily pulling all of it's basically doing the equivalent of a kubectl logs on every single pod, just kind of automatically. Essentially it's tailing the pertinent output file that exists on each of the cluster nodes, and it's just sending that along to Cribl. So that takes care of getting my logs from my cluster into Cribl. And so now I'll go over to our Cribl tenant. As I said, we are using the cloud-based offering. I had done some work in the past with the AWS Marketplace offering, and that was pretty easy to set up. As easy as that was, this was even easier. You just go, you self-register, you get a tenant, it automatically comes with a bunch of standard log ingestion endpoints already set up and listening that you can start sending stuff to. So I didn't even have to set up the Elastic endpoint. It just came with it. So the way Cribl breaks things down is data comes in on sources. It's routed through various pipelines, and then it gets sent to destinations. And so my sources that I'm currently using are the Elasticsearch API, which is pulling in data from all of my pods that aren't part of the control plane. And as Cam mentioned, one of the nice things is you can see live data as it's coming in. So this is live data coming in from my cluster, and I can see how Cribl kind of breaks it down by default. And then from there, I can manipulate it as needed in order to get it to look the way I want it to look by the time it hits HLA. And I found this was a little bit quicker than just using the native HLA methodology, which once I get into the HLA, you'll see is it's a native kind of JavaScript interface. It doesn't have the same interactive point and click type user experience. And I found that really helped me to streamline getting a bunch of data going into HLA. So the other sources that I had to configure were what's called a raw TCP, or sorry, a raw HTTP source, which is ingesting the data from my Lambda function, which is passing, that's kind of my little gateway that I had to create in order for data to come out of CloudWatch and get into Cribl. So actually, that's probably a good time for me to start injecting a little chaos into my cluster. So Mike had pointed out this pretty neat cluster workload you can run called Cube Invaders, and it basically creates a little Space Invaders interface. But as the little spaceship, goes back and forth and shoots at things, these are actually pods in my cluster that it's killing as it hits them with the projectiles that it's firing. And then the little computer icons, those represent my two nodes in my cluster. And what happens when one of those gets hit is the Cube Invaders pod will launch a chaos pod in the node itself, which kind of wreaks a little bit of havoc with the node. So now I've got kind of some mischief going on in there. It makes it more likely that I might see some control plane type traffic coming through on this raw HTTP endpoint. The control plane is normally, if you're in a steady state, it's not necessarily terribly chatty. And so here's an example of all the data that's coming in through that control plane log channel. And then the last source that I set up is what's called an S3 collector. And per the name, it allows you to point Cribl at an S3 bucket, which contains log data, which has been stored from any source, and tell it, hey, go out and troll through that S3 bucket and find anything that contains log data and bring it back into the Cribl stream product. And then it handles it just like any other stream of log data. And so right now, this is pointed at a bucket which has a recording of events coming from my cluster from a previous date. And again, there's a lot of visibility here. I can run the collector in what's called preview mode, which is pretty self-descriptive. It pulls the data down and shows you, hey, here's an example of the data that would come out of this bucket if you were to run the collection routine. And so again, it breaks down the contents of each log entry in a nice navigational format. JSON is your friend with all of this stuff. If it's already in JSON, then this is the kind of experience you get where it kind of compresses your keys down, and then you can expand your keys to see what lies beneath them. But Cribl Stream is completely format agnostic. Whatever format this stuff comes in on, Cribl can handle it and transform it into whatever end state format, whatever end state set of fields you're really interested in. Okay, so now we've got our data. What do we want to do with the data before we send it to where it ultimately needs to go? And that's controlled by what's called packs and pipelines. So packs are pre-built processing modules that Cribl provides. They're also sourced from the community, and you can also write your own. And what they do is they just provide basically a drag and drop capability to say, this is the kind of data I'm pulling in. And you've got predefined transformation rules, which will parse that data, split it up if it's a particular format that sends multiple log records, multiple log events in as part of a consolidated payload. And a pipeline is essentially a chain of functions that accomplishes the same thing. It's just the pipeline is something that you build. The pipeline is just more granular. A pack is basically a set of functions that are bundled together, which you can invoke. A pipeline is, in practice, more bespoke for your particular situation. So an example of a pipeline that I created, which was fairly simple, was as when Michael had asked the question about what are the trade-offs if you're talking about kind of filtering out what log traffic ultimately goes downstream, in this case to HLA. And so when I started sending logs in from my cluster, what I found was the different microservices were generating output, generating logs in slightly different formats. And so I determined probably the best way to go would be to eat the elephant one bite at a time. So I picked one microservice to focus on for what I was going to show you today. And so that service is called the front end. So I just added a function to this pipeline through which the data would flow. And I just used a built-in function that Cribl Stream provides called drop, which drops any log message which doesn't match the specified filter. And so by applying this filter, I'm avoiding sending traffic that's from one of the other microservices that I haven't adjusted and prepared HLA to ingest yet, from showing up and generating a bunch of, because HLA, what will happen is when it gets data, it kind of decides, oh, this is the kind of data that's coming in. I'll give it a default name and I will start collecting samples and learning from that data. And so by adding this filter at the front of that pipeline, I'm preventing that from happening before I'm ready. So the other thing that I did, just to demonstrate how Cribl is a powerful tool which can prepare your log payload so that when it gets to HLA, there's a lot less that you have to do using native JavaScript. And so what I did there was I just added a couple fields that would be added to the payload to generate a friendly severity key and timestamp key, which HLA could basically just read from the get-go without having to write any parsing logic within the native JavaScript function that HLA uses to do that. And it's really, as many things in IT, there's multiple ways to do the same thing. I just found that this was more straightforward to do because of the fact that I could flexibly collect sample payloads such as this one, and then observe how my payload would behave interactively within Cribl Stream. So here's an example. I had saved a raw payload. I can load it up, and then this shows what it looks like coming in. And then by clicking out, I can see that because these don't fit the specified filter for the Kubernetes label, these packets would all get dropped and not get passed along to HLA. So now that I've done my transformation, put the data into the shape I want it to take on before it gets passed along to its ultimate destination, that's when I configure my destinations within Cribl Stream. So by default, there's a dev null, which just gives you an out so that the trail that your data follows, by default, it ends with this dev null, which just kind of sends it to the bit bucket. And that's really just to give anything that doesn't specifically get caught by your filters that you've put in place somewhere to go, so it doesn't end up looping. Or it also gives you flexibility where you can make that fallback something else, such as just dump it all to an S3 bucket, for example. I've created 3 TCP JSON destinations, which correspond to Health Log Analytics data inputs. HLA accepts a number of different protocols. This was just, I chose this one because it's fairly low overhead. We also include, we can listen for various other protocols like Elastic. There's a REST endpoint as well, which takes a more kind of rigid REST API type interaction. I found the TCP data input to be really lightweight and easy to work with when connecting to Cribl. So that's the one that I've used. And just for simplicity's sake, I've got a few different ones just to give me a little more flexibility with setting up how they get handled once they get into the HLA side. And again, there's constant transparency where just like with sources on a destination, you can kind of snoop in on live data and see what that looks like. You can save it off as a sample file, which you can then, use to further adjust and curate how your transformations are taking place within the tool. And then the other destination that I set up is an S3 destination. One of the challenges that we get sometimes when we talk with customers about HLA is they're looking to kind of revamp how they handle logs, and they like the analytical aspects of HLA, but they still need to solve for things like long-term retention, archiving, ad hoc querying. And Cribl can help with that because we can have our data send not just to HLA, but also to some type of archival storage. I'm using an S3 bucket, but Cribl has native support for Azure, Google Cloud, as well as a number of other endpoints that can ingest and retain log data.
A good one to call out here is Minio. So Minio is an on-prem, I'll say S3 storage emulator. It lets you basically send to an S3 API, but it's a on-premise emulator essentially.
Nice.
Yeah, so it acts the exact same way as Google Cloud Storage or Amazon S3.
So in my case, what I did once I had my log traffic kind of bifurcated going to HLA as well as S3 was I just set up a quick proof of concept, Athena Database. Athena is Amazon's tool that lets you use SQL to query data that's in S3. So here's my raw logs, and I can just run this example SQL query against my pod logs and dump out really whatever specific information I'm looking for from the logs, even if it's not something that I was that I knew that I was interested in when the log was being generated. And there we go. So that kind of covers how I'm getting my logs from my cluster through Cribl, sent off to S3 as well as HLA. Now on the HLA side, what that looks like is data coming in via what's called a data input. Data input records are what instantiate a listener. And per that diagram that Mike had that showed the architecture, the listener is running on your mid server. And so I've got some different endpoints that I'm listening on. 3 of them are active. I've got one for my control plane, one for the pod logs, and I've got one that's taking my playback from my S3 bucket when I trigger that. And so just a quick look at what a data input record looks like. So this is where I tell it what kind of data input I'm using. I'm using a TCP listener. I give it a port to listen on. I want to be super safe, so I'm using TLS. And then down below it says, hey, yeah, I've got this guy here is sending me data, and here's the log lines per second that are going through. So this is kind of the front door for HLA. Once it hits that data input, the next step in the path is called the data input mapping. Data input mapping is where we tell HLA how to determine what service within your CMDB is being reported on. And so there's a couple things to just call out here. One is the fact that HLA is sampling your data, and that's, gives you a way to interactively kind of tweak how you're parsing the data and see what the result is prior to hitting that publish button and kind of committing it into the system and telling the AI, okay, you can start observing this data and determining what's my baseline, what's considered normal, and be on the alert for when things go outside the bounds. And that can be seen in this middle section here, where it basically takes your samples and runs it through your JavaScript code, whatever JavaScript code that you've put in place to kind of guide it, to tell it what application service this message corresponds to, and then further break it down into a component of that service, and then what's called a source type. And the source type is kind of the next step in our journey. Source type in health log analytics speak means file format. And that's really where you make sure that health log analytics understands how to pull out the important nuggets from a given piece of log data. And so here's an example. And what health log analytics does is it ingests your payload. And again, you've got samples that you can draw from to pick exemplars and make sure that it's working correctly against any kind of variance that you have in the logging that's coming through that particular service. And then down below are all the keys that it's pulling out. And then all you have to do is just make sure that the keys that are coming out of your payload are tagged appropriately. And Health Log Analytics is really looking for a couple key tags. It's looking for a severity tag, a timestamp tag, and a message tag. Those are kind of the three bare minimums. And then there's some additional tags that you can assign. You can assign a host tag. That's generally something that you want to do because that's what helps tie it back to a CI in your CMDB. And the result is you get alerts like these. So this is application service that I defined in my instance corresponding to the boutique application made up of multiple microservices running on my cluster. And then because I've been firing, the Space Invaders have been getting blown up left and right. I've got pods dying and chaos ensuing inside the cluster. And so as a result, I get a bunch of alerts where they're coming from a pod. You'll see it'll refer to the specific pod that's being impacted here. And so that's kind of the end-to-end journey. And just to reiterate how Cribl makes it better is the ability to route and pipeline your data on the front end before it hits HLA means that your log sources, your endpoints that are generating log data, they just need to be set up once to send their data to Cribl. And then you can adjust and slice and dice how the data looks and where the data goes without having to involve application teams and repoint things and deal with, kind of that very low level granular change within your environment. And the other call out is just, I found it very, very easy to get the data to look how I wanted it to by funneling it through Cribl first, just because of the fact that it's as simple as just hitting that live data tab and you can see the data at any of the points along the way and see what it looks like. It just made it very easy to adjust things. So by the time it hit HLA, I had minimal things I had to do. Any questions? All right, Mike, if you're still there, did you want to just touch on your breakthrough with the containerized mid and the
Yep.
and the role?
Yeah, definitely. So the key thing here is, and we'll send this out as part of the slide deck when we get back, when we get done, is that prior to getting this figured out, in order to do discovery of AWS, right? The best method and the most recommended method from AWS standpoint was to use an instance profile, right? And then use assume role capabilities from that instance profile. And it was great because then you didn't need to manage credentials in the ServiceNow platform, and you don't have to, pass around API keys and API tokens, which most AWS customers are not wanting to mess with anymore for security reasons. So, but at the same time, we didn't have it documented really clearly on how to do an instance profile with a containerized mid server. And so I documented that there. There's the two links on this slide are to my GitHub repo and the community article, both the exact same article, just two different places if you want to go check it out. Bottom line, you have to build out and attach an OIDC provider to the cluster and then pass that IAM role down into the cluster and then map it to a cluster role inside that cluster and then fire up the mid server as that cluster role. So it works quite well, and finally enables us to do containerized mid servers using credentials discovery for AWS. So kind of I think a big important thing that we needed to get hashed out. So I'm glad we got that worked out. Feel free to go check out the links, and as always, drop me a note or add a comment to the community article if you have questions. I think that was it for the kind of demo portions, and we're actually kind of just bumping up against time. I know some people may need to leave, but for those that don't, as always, we open it up for questions and answers at this point. Anything that you want to talk to us about around Kubernetes, about ServiceNow, whatever it may be, now's the time. Feel free to jump off mute. I think maybe let's stop the recording, so if people want to ask questions, they can feel free.